Hi, I'm Daniel Castaño and I'm going to show you how to click particles in Dynamo. Now we're going to focus on isolated particles. Let's see what we have here. So, ls, we have this tomogram, prd1.mrc. We can take a look what it looks like with dtmview on the fly so that we only take a look at the particles on the sections that we need. So, copy paste and we move in the tomogram. Well, we see those are different phases in suspension. Let's take a look. Well, I guess you see them. So the tomogram is not too big, so it's 1K times 1K times 100 pixels, so that we probably do not need to do anything special. We can just open it with TomoView, which is the tool that we are going to use to click on isolated particles. dtmview on this file. So dtmview is saying that it doesn't know the file, so it has created a catalog in order to index the file inside. We don't care about that right now. And we just let TomoView opening the tomogram. So it's basically reading it and transferring all the tomogram into the memory. Well, apparently there is a model pool already in our memory. We don't want that. We go to model pool and we clear it from the current status. And now we see what we have here. In this screen, what we have now is a single slice. We can choose how many slices are projected, and we can move the slice up and down in the tomogram. But actually, that's not what we want. Let me check a little bit the contrast. See, what we move, we select different images. Actually, we can probably focus on part of the image. Let's see. I want to zoom here so that I take the up arrow to limit the sun here, and the right arrow to limit the scene here, and well, we can go up and down here. What you see, the typical browsing on a tomogram. So how do we click these particles that are on different heights? Well, what we do is we go to active model, we go to picking profile, and we select the isolated particles. So that what is going to happen now is that the scene that we have here, the main scene, represents a projection of all the slices. So that we see everything that is in the tomogram, or at least in this part that we are focusing on. We see here the geometry of the part that we are focusing, but that's a vertical projection. So that if we click here in this scene, we can define a particle in xy, but we still need to define z. In order to do that, we connect the support viewers and we click with the secondary click in the center of one projection, for instance here. And Dynamo thinks a little bit and creates this depiction, which, well, you can see what it means. Using this green color is the same green that you have here. Basically what Dynamo is doing is giving you the Z extent corresponding to this plane, and the same for the yellow plane. So that if I click here with the main click, Dynamo will accept the XY that we defined in the main scene plus the Z coordinate from this, and it creates a point that is three-dimensional. So we can do this for all the particles. There are different parameters that you can tune in order to make the representation easier. You can select a bandpass for the screen, for the display of this local section. You can select the number of slices that you want to get depicted. But well, so patiently you see the mechanism. We have to click twice for each particle. This particle, for instance, we see that the Z is rather high, so that probably it will be discarded by Dynamo when we try to crop it. You see it's too close to the boundary, but well, we click it anyway. But well, now that we know that these particles are probably not the best, we can actually move to the next one. And this is better centered. Let's pick a few more, and then we will see how to actually crop them out of the tomogram. So let it be the last one. So we have an active model that has been taking all these clicks. Here, active model, which is telling us that there are 13 points, but only 0 crop points. That's a formality. We have to inform Dynamo that these points, all of them, all the points that we clicked are actually points where we want to crop particles. That's done. And now we can do several things. We can save the model into the catalog so that we can come back and crop particles from several models and from several tomograms at the same time. But we can also just show how the mechanism works for this particular model, so that we can crop particles in active model, and we get this window that is proposing us this name for a data folder where Dynamo will store the particles that we crop out of this single model. Here there is nothing much to do, only to select the side length. Let's put 64 for instance, and we just start cropping. So the model has 13 points. Actually, we are going to have much less particles because 8 particles were excluded. I mean, we were just clicking particles that were too close to the tomogram, so that only 5 survived. Let's see them. With DD Browse, we can access the generated data. Actually, we see that Dynamo has generated this data, and inside this data folder, it has created already a crop.tbl, a table that we can use in order to talk to the particles to index them. So here that's the range of tags that we want to see. In this case, we just leave the start, all of them, and let's see from the Z view. So show, those are our particles. We can take a look from the Y direction, the missing Y direction, and we can even view the different particles. We select one of the particles, we secondary click, and now that's a different representation of one particle. Here, the particles that we get with DD Browse are projections of one single particle, and we can select one of it to see the table properties attached to a single particle. In any case, you see that that's all we need in order to do subtomogram averaging. Obviously, this case is very reduced. You need more than 5 particles, but we have a data folder and we have a table, so that you can create an alignment project. Before closing this session, I just want to show you that if we come back and close all the windows, if we come back to our directory, we'll see that we have our original tomogram, we have this folder of particles, and we have a .ctl. This is a catalog object we can open with dcn-c default. That's where Dynamo just put the particles that we created. So we have this tomogram. Dynamo doesn't know anything about the focus, epic, Fourier sampling, how to put it, but probably Dynamo knows that there is a model file attached to the tomogram. So that if we want to crop particles again, we will select it and we get a direct link to the tomogram and to the model. So that's all for today. Thank you for listening.